Hello and welcome to, this is IB Math AI, not Math Studies, sorry about that, lesson 1.2. So here's an interesting question. How do mathematicians reconcile the fact that some conclusions seem to conflict with our intuitions? For example, we can find the area of things that have infinite perimeters. Yeah, it can be done in calculus. We'll do it this year. When we do integrals, there are shapes with infinite perimeters, yet they have a finite area. How is that possible? What if I told you that the numbers, the natural numbers, added up to a negative number? All the positive natural numbers add up to a negative number. That's interesting to think about. Anyway, how do we reconcile the fact that some conclusions in math conflict with our intuitions? Have fun with that one. Alright, we're in sequences and series today. A sequence is a list of numbers which follow a pattern. One of my favorite sequences is the Fibonacci sequence. I'll give you a presentation of that on the end of the year. The numbers in a sequence are called its elements or its terms. So we got some words there. Elements and terms of a sequence. Sequence is going to be defined by, we can just list it out. So here's a sequence. Here's the Fibonacci sequence actually. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. Do you see the pattern? If it has a pattern, then it's a sequence. We could use words. All odd numbers between 50 and 100. So here would be our sequence. 51, 53, 55. Dot, 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 all the way to the last odd number in there. This is the first term. This would be the last term, second, third term. We could use set notation like this, where you've got brackets. This is the nth term, u sub n. The nth term meaning there's n terms. N is unspecified, so you just keep going in your sequence. This is the first term, second term, third term, fourth term, until you get, that's the second to last term, that's the n minus 1 term, and then you get to the nth term, like that. And that's our whole sequence. Stops when you get to the nth term. A formula for general term, or the nth term, is given by this could be a sequence where n starts at 1. You always want to start at 1. So if I plug in 1, 2 times 1 minus 1 is 1. Now you go and you plug in 2 for the second term. This is the first term. And now for the second term, you plug in 2. That's 4 minus 1 is 3. That's the second term. And then you plug in 3. So to get the third term, we plug in 3. 6 minus 1 is 5. To get the fourth term, we plug in 4. 8 minus 1 is 7, and so forth and so on. That's what a sequence is. A series is taking a sequence and adding the terms together. It's the sum of the terms of a sequence. So if you have 1, 2, 3, and 4 like this, find the sum of the first 10 numbers in this sequence. So all you got to do is just add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, like that. You get 55. So S sub 10, the 10, adding up 10 terms of the sequence ends up at 55. Okay, now find S100 of this same sequence. Go ahead. S100. Think about it. Do you have an answer yet? Can you add up the first 100 numbers? I need you to pause the video and go watch this. Go watch the video on Carl Friedrich Gauss. He was an 8-year-old when he was asked to do this, and he figured it out in a very short amount of time. Here's an interesting result. This is what I was talking about up here. using this sequence right here, 1, 2, 3, 4, and it goes forever, the sum of an infinite number is negative 1/12. That's kind of interesting. Believe it or not, you're not going to believe me. I know you're not going to believe me, but if you add up all of the numbers, 1, 2, 3, 4, 5, 6, 7, blah, 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 you end up at negative 1/12 when you add them up. It's pretty crazy, isn't it? You don't believe me. What if I could prove it to you? Would that change everything you think about the universe? Alright, anyway, Carl Friedrich Gauss, 8-year-old mathematician. Well, he wasn't a mathematician at that point, but he becomes one of the most influential mathematicians of all time. And in fact, he is in your math lineage, meaning he taught a guy who 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 continues to teach people, who eventually taught me, and now I'm teaching you. So you are in the lineage of Carl Friedrich Gauss. So you watch that video, pretty cool. Arithmetic sequences, we got to move on. Arithmetic sequences in series. Each term differs from the previous term by a fixed number called the common difference. Common difference. Alright, for example, when you take one of the terms of a sequence and subtract the next term in the sequence, you get D, called the common difference. This means that the difference between two consecutive terms is D. That's what we use to show that, and we'll go through some examples. So like up here, if I take 4 minus 3, that's 1. If I take 3 minus 2, I get 1. If I take 2 minus 1, I get 1. There's a common difference between these terms of the sequence. What's 4 minus 2? 2. It's got to be consecutive. To get the common difference, it's consecutive. So from this video, Carl Friedrich Gauss video, he was able to come up with the formula, actually, kind of in his head, for the sum of n terms, if the last term is known. So he was able to plug in 1 as the first term when he's summing up to 100, and then 100 divided by 2, and he figured this out. Now, these formulas are in your formula packet. So pause the video right now and get out your formula packet and go take a look and find these formulas. This is the sum of an arithmetic sequence. Should be in topic 1. So sum of arithmetic sequence. Okay, you're back. You've paused the video and you've looked. There you go. So in an arithmetic sequence, here's an example, like 2, 4, 6, 8, 10, 12. There's a common difference. 12 minus 10 is 2. That's the common difference. 10 minus 8 is 2. That's the common difference. And then there's the geometric sequence. So there's two types of sequence that we're going to study, arithmetic and geometric. The geometric sequence does not have a common difference. It has a common ratio. Okay, and the common ratio is each term can be obtained from the previous one by multiplying by the same number. So instead of 2, 4, 6, 8, it's 2, 4, 8, 16, 32. Because I'm multiplying by 2. Instead of adding 2 every time, I'm multiplying by 2 every time. That's the difference between arithmetic and geometric. So arithmetic, you're looking for the difference. Geometric, you're looking for the ratio. Alright, if R, which is called, we call that that's R, the common ratio. If the common ratio, absolute value, is greater than 1, then the terms of the sequence increase. Like this. In this scenario, R was 2. And every time you increase, you get bigger. If R is less than 1, you decrease. For example, if we went 32, 16, 8, 4, 2, 1, 1/2, What's the common ratio here? What am I multiplying to get from here to here? Multiplying by half. So in this scenario, R is a half. Okay, so if you're going down in size, it's a half. If you're going up in size, it's bigger than 1. And then you could have something where the ratio is less than 0, so you have a negative ratio. And in that scenario, what happens is you alternate. And so if this was negative 1/2 as my ratio, you start with 32 and then negative, that would take that to a negative, and then a negative times a negative would be positive, and then a positive times a negative would be negative, and then a negative times a negative would be positive, and then you get a negative, and you'd have alternating negative, 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 what's called an alternating sequence. Alright, here's the summary of all of your formulas. Here's your arithmetic, and again, this is in your formula packet, so you do not have to memorize these. This is for the nth term. If you want to find, maybe I want to find the 10th term of a geometric sequence, or the 51st term of an arithmetic sequence, I can use this formula where I just plug in the first term, I plug in the number of terms I want, and I plug in the common difference. You get two equations for the sum of terms. This is if you know what the nth term is, and this one does not require the nth term. There's no use of n there. So you can pick which one you want to use to find the sum. Then we have geometric. This is the formula for geometric sequences to find the nth term, and this is the formula to find the sum of n terms. Alright, let's do some examples. That was a lot of information. So let's figure this out here. Determine whether the sequence is arithmetic or geometric or neither. So let's just go through and do that real quick. What's happening here? It looks like to get from 6 to 24, I can either add or I can multiply. I'm thinking multiply by 4, multiply by 4, multiply by 4. So therefore, this is geometric, and R is 4. The common ratio is 4. What about here? It looks like 3 minus 4 minus 4 minus 4. There's a common difference. So this one is arithmetic, and D is negative 4. Common difference is negative 4. Down here, it looks like a very similar one, I think. Well, maybe. Minus 4. Negative 11 plus 4 plus 4 plus 4. That's arithmetic, and this time D is equal to 4. That's just a coincidence that they're all 4s. Okay, getting a little harder now. How do we get from here to here? Now, this is alternating, because this is negative, positive, negative, positive. And it looks like if I multiply this by negative 3, I get to this. If I multiply this by negative 3, I get to this. If I multiply this by negative 3. So this is geometric. R equals negative 3. And then there's this one. Let's see. This is negative, this is positive. I don't think this is anything. I'm multiplying the bottom by 2, and then I'm adding 4 to the top. Yeah, this is different. The bottom, the denominator is geometric, and that it has a ratio of 2. The top is arithmetic. It has a common difference of plus 4. But when you put those together, there's nothing there. There's nothing going on there. This is neither. Alright, so now let's go up to this top one, and then the rest of the directions. Find the next number in the sequence. So times 4 is 1536. We would write that's the fifth term, U5. That's the fifth term. Here we're subtracting 4. It's the fifth term. Here we are adding 4. The fifth term. And then lastly, here we're multiplying by -3. So that would be -111 over 2. Oh, whoops, 27 times 3 is 81. Not 111. I did 37. There. And that would be the fifth term of that sequence. Next, write the formula for the nth term. So this is the fifth term, and we can write a formula for the nth term. The nth term, this is geometric, and this is un equals u1 times r to the n minus 1. Okay, so the nth term, that's the nth term, in this scenario is going to be equal to the first term, which is 6, times the common ratio, which is 4, raised to the n minus 1 power. And that's it. There it is. This is how we can find any term. So if I want to find the second term, you plug in 2 right here. 2 minus 1 is 1. 4 to the first power is 4. 6 times 4 is 24. See how that works? If you plug in 3 here, you're going to get 96. If you plug in 4 here, you're going to get 384. That's the nth term. And looks like I'm going to run out of room, but if I want to find the sum of the first 10 terms, you can use, it's geometric, so we use this equation right here. Let me write it out fully. Okay. So if I want n is equal to 10, sum of 10 terms, the first term was 6, r was 4, keep n, and then all over r minus 1. So there it is. And there's quite a bit of math that goes into why these equations work. For now, you just have to trust me. So yeah, we can plug in 10 because we know that n is 10 in this case. We want 10 terms. So plug this in your calculator. Work inside the parentheses out. So 4 to the 10th minus 1. That's in the parentheses, times 6, okay, and then divide by 3. 4 minus 1 is 3. Oop. Come on, divide by 3. That takes this number and divides it by 3. So it's a pretty big number. And because we're in IB, we're going to do 3 sig figs. Right? Yeah, that's 3. That would be 3 sig figs. These are your 3 significant digits there. So that one has to be rounded up. Those are 3 sig figs there. So that got pretty big at the end. That's because you're multiplying by 3. So this is the sum of 10 terms of this sequence. For the arithmetic sequence, I'll do one of them. In fact, I'm going to have to cut this video off and do that on the back. Alright, I'll see you in the next video.